All right, guys, I'm about to go over review or the semester review part 1. So let me get to it. Let me clear these. All right. So for number 1, here we have to make this continuous, the situation continuous. So if you remember, to make it continuous, that means we don't have any asymptotes or any holes or any jumps. In this case, we'll probably have a hole because we can't plug in -3 because the denominator is 0. So that means we need to factor out to see where we do have the hole. And then once we know where the hole is, we can just set k equal to the hole because that means that'll fill it back in. So however you factor out this top, I know everybody learned it different ways. So however you do it, go ahead and you end up with 2x let me see, minus 1 and x plus 3. Yeah. So that'll end up being -1x, 6x. Yeah. All right. On top, on the bottom, that's the difference of squares. So that's x plus 3, x minus 3. Perfect. Now we see that the x plus 3's cancel out. So now we can plug in -3. Before we couldn't because we get 0 at the bottom. Now we won't. If we plug in -3, now we would get -6 minus -7 over -6, which equals 7 over 6. So be careful if the signs mess you up. Look, they have ones that have the negative. Be careful. All right. So there's number 1. Number 2, something similar, but it wants us to identify the vertical asymptote. So that's when the bottom equals 0. So a common mistake is people want to factor the bottom right away and get x plus 2, x minus 1. So they want to say there's 2 asymptotes, one at -2, one at 1. That's not true because we have to factor the top out and get x plus 4, x minus 1. So the reason why, because the x minus 1's cancel out. When something cancels out, that's not a vertical asymptote anymore. That is a hole. So we can't include 1. When x equals 1 is not an answer, but they have it there to mess with you. So the only place that we have a vertical asymptote is when x equals -2. Number 3. Here, if you remember this is a problem using the conjugate because we can't plug in 9 yet. So we have to find a way to cancel this x minus 9 out. That's what's causing the issue. So we multiply it by the conjugate, which is x minus 5 in the square root plus 2. We got to do it on top and on bottom. So I know it's been a while, so here we go. So when we multiply that ends up just being x minus 5. -2 times +2 equals -4. Here, we don't want to multiply this out because we're trying to cancel the x minus 9 out. That was the whole point of doing this. So if you notice, this ends up being x minus 9 on top, at -5 minus 4. So there we go. That's what's going to cancel this out. I'm just writing it to show y'all where I am. So now I'm left with, don't forget about the 1 on top. All right. So now we can plug in the 9 because now the x minus 9 was the issue and that got canceled out. So now we just plug that in and we get our answer, which is 1/4. All right. Number 4 here. Sorry. We have, All right. We have this problem. We can't plug in the 2 right away because it would give us 0 at the bottom. So we have to see if it cancels out. Sometimes it might, sometimes it might not. Let's see if we can cancel this 2 minus x out. Let's factor the top. X plus 3, x minus 2. All right. So it looks like we can cancel this out right away, but be careful. This is not the same thing as this. This is like saying -x plus 2. So what we can do, if we want to try to change it to make it look like this, what we can do is, or I'll write it down here. Here we leave this alone. Here we leave this alone. At the bottom, to change, anytime you want to change the signs, you can factor out a -1. That means it's -2 plus x. Because like if we multiply that back in, it would go back to this. Or you can just have a negative sign. We don't really need the 1 as long as you have the negative. But either way, if you like the 1, you can put it. So now this is the same thing. X minus 2 is this right here. It's just flipped. You can put this in front if you'd like to make it look like that. I don't know what's happening now. Doesn't look like it wants to. All right. So now the 2 minus x is canceled out. Perfect. So just don't forget that we have this -1 there, because guess what? They have an answer if you forgot that -1. Now we can plug in the 2, so that'd be 5 over -1, which is -5. So they have that phi there, and they have this e here to mess with you. Either way, so be careful. All right, here they want the derivative, so let's rewrite this. It's giving me trouble. All right, give me a second, guys. Let me cancel this out. Sorry, sometimes it does this. Import. All right, here we are. So let's rewrite this as 4x to the -3. I just brought that up. You could do quotient rule if you really wanted to, but we don't need to because there's no x on top. So I'm just going to bring it back on top. Now let's get our derivative. -12 x to the -4 power, because we minus 1. So that ends up being, sorry, this is our derivative. -12 over x to the 4th power. So there we are. Look at this. All right, choice D. They have D to mess with you again. Be careful with the negatives. All right, so let's go on to number 6. Here we have an implicit problem. That just means we have x and y at the same place. So here, to take the derivative, we got to do product rule. So f g prime plus g f prime equals 4 plus 2y dy dx. Remember, anytime we take the derivatives of y's, that's why we have to put dy over dx. You can move it over. Let's say we move it over to the left side. You can move it to the right side if you want, whatever works for you. Again, it's not wrong either way. This is just the way, sorry, that I'm used to doing it. So I'm just going to rewrite this as 3y. I moved it over there, and I moved this over here. So now I can factor this out. Oh, sorry. So again, I know some of y'all can do some of these steps in your head, but let me just write them all out. All right, so we're here. So now if we look at our answers, A looks pretty good, but look at the bottom. The signs don't match up. What else? D, the signs don't match up. E, the signs don't match up. So I have no correct answer that matches mine exactly. But again, what we can do is if we can change all our signs on top and the bottom. It's like saying 1/2 is equal to -1 over -2, which is true. So you could change all the signs on top and all on the bottom if you want them to make it equal. So -4 plus 3y over -3x plus 2y. So I basically just factored out a -1 on top and -1 on the bottom, and they canceled out. So now let's see. Here we go. -4, positive 3y, positive 2y, negative 3x. D is our correct answer. So it looks like if we had moved the dy dx over to the right side from the beginning, we probably would have got this answer without having to change our sign. So sometimes on multiple choice, you got to be careful. Again, there's no right way. They just like to mess with you. So just be careful. All right. Number 7. Here, find the second derivative of this. Okay, so they give us our original. Be careful what they give us, the original. Now let's find the first derivative. F prime equals 4. That ends up being chain rule. All right, there we are. So to make this a little easier, let's multiply the 2 and the 4. The reason why it looks a little easier to do our second derivative now. Same thing, multiply the 3 and 8, so that's 24 times 2x plus 3 to the second power times the derivative inside, which is 2. Go ahead, you can multiply the regular number is 48. We can't distribute that in because of the exponent. This is squared. The only way to distribute it is if we expand this, but look at our choices. They don't want us to expand it. Look to see, oh, use our correct answer. And there we are. All right, cool. Number 8. Here we have another chain rule problem. So here is just the first derivative. So that's y prime equals, oh, yeah, let's do this. 4 sine 3x. Let's rewrite it like this to make it look easier. So now, since whenever it's squared with the trig, that means the whole trig part is squared. So as chain rule, we do the outside 8, leave the inside the same, to the 1 power. We don't really need that. Times the derivative. Here, let me write it over here. Times the derivative of the inside, which ends up being cosine 3x. And then we have times this inside part, the derivative is just 3. So there we go. So we had chain rule twice. We had this outside, then the inside, and then this inside, the 3x part. So now we just see, you can multiply the regular numbers, 3 and the 8. That becomes 24. And then the sine and cosine just stay there. So correct answer is E in this case. All right, let's go to number 9. Number 9 looks crazy with all these values from the table, but just do one piece at a time. They define this as P of X. So what we got to do is take the derivative of each part. So it wants us to find the derivative of P. So that's product rule. F G prime. To get the derivative of f of x, we just put f prime of x. So that's f g prime plus g f prime. All right, so that was just this part right here because I split this up, f and g. All right, then minus the derivative of that. Now we have chain rule. So the derivative of the outside, which is just g prime, leave the inside the same, times the derivative of the inside, which is just 3. So here we're at. Now all we have to do is plug in 2. So I'll put up here. 2 times f prime of 2 plus f of 2 minus g prime of plug in 2, 6, 4 times 3. So now the table. So we're not going to use all of these. They give you a bunch of them to mess with you. All we're using is these. So that's 2 times f prime of 2, which is 1, plus f of 2, which is 5, minus g prime of 4, negative 1 times 3. So that's being 2 plus 5 plus 3. Ends up being 10. There we are. All right, number 10. Change the color. Number 10 is a related rates problem. So we have a cylinder that is getting bigger. So let's see. At this specific moment, the height of the cylinder is 12, the radius is 4, the circumference is increasing. That means the rate of circumference is pi over 4. The height of the cylinder is increasing, so the rate of the height, 4 times faster than the radius. So it's 4 times faster than the radius is increasing. So we don't know what either one of these are, but they know that we're connected. So if we find one, we'll know the other one. How fast is the volume changing? So they want to know dV dt. All right. So they give us these. So we'll have to use this to figure out some of the stuff. So we know the circumference of a circle is 2 pi r. So we take the derivative of that, ends up just being 2 pi dr dt. Plug in our stuff, we end up getting negative pi, or sorry, not negative. We end up just getting pi. I want this. Let's hide this. All right. Pi over 4 equals 2 pi dr dt. So now we'll be able to figure out what dr dt is. So dr dt, you end up dividing that, the pi's cancel out, and you end up getting 1 over 8. I just divided pi over 4 divided by 2 pi, and the pi's canceled out, and the 2 stays on the bottom, so we get 1/8. So now we get dh dt. Look over here, dh dt is just 4 times whatever that is, so that's 4 over 8, which is 1/2. So we did all this. Now we don't even care about the circumference because they're really asking about volume. We just use that in order to get some information. So now we can go from there. So my volume equals pi r squared times h. All right, here we have dr dt, dh dt, r, and h. We have everything we need. So now we can just go ahead and do this. But yeah, we're going to take the derivative using product rule. So that's dv dt equals f g prime plus g f prime. All right. So now let's plug all our stuff in. Pi 4 squared times 1/2 plus 12 2 pi r. So that's 2 times pi times r, 8 pi times 1/8. All right. So now let's see. We got to actually do the math for the multiple choice. So that's 16 times 1/2 is 8. 8 pi. This ends up being 8 pi times 1/8 is just pi. So that ends up being just 12 pi. Add those together. These are just like variables. You can add the numbers up, and that equals 20 pi. Or like terms. And there we go. So I know most people don't like related rates. This is why. But you guys can do it. All right. Going back to what we just recently did. The graph of f prime is shown below, or shown above. When is f concave up and when is f increasing? So that's when f prime, f double prime is positive, and fx, that's when f prime is positive. All right, so we don't have f double prime, we only have f prime. So this is also the same thing as saying when the slope of f prime is positive, or another way of thinking about it is when f prime is increasing. These all mean the same exact thing. So let's see. When f prime, this is f prime, remember, when it's positive, that's all this right here above the x-axis. But now we have to see when the slope of f prime is positive or when f prime is increasing. So that's when it's going up. It's going down, now it's going back up right there. All right, so now we can answer the question, sorry. From -2 to -1 and 0 to 1. That's D right here. Perfect. All right, let's go on another limits problem. Let's get one. No. All right. Here, they're asking for as x approaches infinity. All right. So if you remember that, that means as x keeps going on forever, is the graph going to go up forever? That means it doesn't exist. Or if it goes down forever, or if it kind of levels off. So the way to figure that out is that's top heavy, bottom heavy. But here, they make you work for it because they don't give you just the equation. If you think about it, if you multiply it, all we care about is the leading coefficient, the part with the biggest exponent. So that's going to be 2x times x right here. So that ends up being negative 2x squared. Okay. The bottom, so it'll be whatever. We don't care about the rest of this. We just care about the biggest coefficient. But if you wanted to actually FOIL it all the way out, you can. Here, we have just x times x. That's x squared. So we have to see, is this top heavy, bottom heavy? What I mean by that is the exponent, or is the degree bigger on top or on the bottom? They're actually the same. They're both x squared. So when that happens, these end up canceling out, and we just end up having the coefficients -2 over over 1. So -2 over 1. So our answer would just be -2. So we have notes explaining this. If you don't really remember this, you can go back to it's the limits in that first unit. Go through it. If you need help with this, if you don't remember it, tell me in class. I'm happy to help you. All right. Number 13. They want the derivative. So here we end up just splitting this up and doing product rule. So that's f g prime. We end up getting, here, let me put brackets to make it easier. We end up doing chain rule. So that was f g prime plus g f prime so there's our product rule. So now we just have to kind of see. The bad thing about this now is none of these look like this, so they kind of simplified this. So now we have to see what can we do to make our answer look like one of these. So whenever you have that, you're in this situation, all we have to do is look to see what we can pull out. So we have two parts. The plus separates it. We have this and this. So let's see. We have x squared plus 2. That's here. That's here. I guess that's really all that's here in the second part. So we can't pull anything else out. So let's say I pulled out x squared plus 2. This had 2 of them, this had 3, so we can pull 2 of them out. And now let's see what's left. This x minus 1 is still here. The 3 is still here. We took both of these out. this 2x is still here. All right. Plus, we still have this plus. 2 of these came out, but we still have 1 of them. So we just did to the 1 power. I don't need to write that. 1 I don't really need. All right. So this is where I'm at. So now we just got to have to clean this up a little bit and then we'll be done. This on the outside, we're good. Here, multiply this, ends up being 6x. Distribute that. 6x squared minus 6x plus x squared plus 2. Right here. Let me not do that. All right. So what does that simplify to? X squared and 6x squared, 7x squared minus 6x plus 2. So there I'm at. So x squared plus 2 squared, and then we have this. That's how I got D as my answer. This right here, this was just me simplifying it. So I simplified this into becoming this, then I just added the like terms. So yeah, it was annoying. We did product rule. This is the calculus, then this is just doing the algebra, simplifying it. All right. Then now we get to the last page. Plug in 0. Can't plug in 0 because we get that on the bottom. So let's see if something cancels out. If we can get it to work out. Let's see what we can factor out on the top. X squared, so that's 5x squared plus 8. Let's see what we can factor out at the bottom. X squared, 3x squared minus 16. The x squared is canceled out. So now if we plug in 0, yeah, we could plug in 0 and it'll be all good. So there you go. So if we plug in 0, that'll be 8 over, plug in 0 here, negative 16, which equals negative 1/2. So it wasn't that bad. It looked complicated, but once we've just pulled out the x squared on both the top and the bottom, that was simple. All right. Our last problem now is asking what's true. So let's see. Here's f of x. Does it have a limit at 2? That means the left and the right side both have the same if you plug it in. So basically here, x plus 2, x minus 2. That's just this factored. X minus 2 cancels out. So yeah, so if we plug in 2, the left and the right side would both be 4. We would just have a hole there, but remember, so it would look something like this. At 2, it would just be an empty hole, something that looks like that. But the limits on the left and the right side both go to 4. All right, so this is true. Is it continuous? The only way that this would be continuous is if it's filled in. So right now they're saying it's filled in at 1. If we plug in 2 into this, is our answer 1? No. So that means they didn't fill in the hole, or they filled it in down here somewhere. Is it differentiable? Well, if it's not continuous, we can't take the derivative. We can't take the slope. If we zoomed in super close and looked at the slope, it's a hole. There's nothing there. So no. So our only answer is A. And there we are.